This video looks at reflections in the line y equals mx. Now, remembering that your gradient of a straight line is m equals tan theta, and that's because it's rise over run. So if you're thinking about your triangle that's on a line, this is your theta, this is your y value, this is your x value. So your gradient is rise over run, which is y over x, y is sine theta, x is cos theta, so that's tan theta. Okay, so that's a little background behind that. Now, consider the line LL dash with inclination 60 degrees through the origin and the vector v 4, 4. So you can see this in the diagram. The reflection of a vector in a line of slope theta through the origin is the same as the reflection in the x-axis followed by a rotation through an angle of 2 theta. Now, you don't need to know how to derive this. I just thought it might help to see where it's coming from. So for the vector xy, the reflection in the x-axis, our x would stay the same, but our y flips sign, as we've already covered. So it becomes x negative y. Now, rotation through an angle of 2 theta, remembering our rotation matrix is cos theta, negative sine theta, cos theta. So that becomes x cos 2 theta minus y sine 2 theta, x sine 2 theta plus y cos 2 theta. And then doing the reflection simplifies to x cos 2 theta plus y sine 2 theta, x sine 2 theta minus y cos 2 theta. And that's where your matrix comes from. Okay, so you've got cos 2 theta, sine 2 theta minus cos 2 theta. Now that is on your formula sheet. So you don't need to know how to derive it. Thought it might help just to see it. That is why we have done this after doing reflections and rotations. So you can see what's going on as opposed to doing it as a part of reflections. Now let's look at some examples. Find the matrix that will reflect the point xy in the line through the origin at an angle of 30 degrees to the positive direction of the x-axis. So our rotation matrix is cos 2 theta, sine 2 theta, sine 2 theta, minus cos 2 theta. Plugging in the angle, that becomes cos 2 lots of 30 is 60, sine 60, sine 60, negative cos 60. Now, knowing your exact values, cos of 60 is a half, sine of 60 is root 3 on 2, sine of 60 is root 3 on 2, and our negative cos of 60 is going to be minus a half. That's done. Now find the matrix that will reflect the point xy in the line y equals 2x. So we have our gradient there. Our gradient equals 2. So that means tan theta equals 2, which is the same as 2 over 1. So we think about our triangle. Theta, this is 2, that's 1. So that means my hypotenuse, c squared, is going to be 1 squared plus 2 squared, which is 1 plus 4, which is 5. So our hypotenuse is the square root of 5. So from there, cos theta is adjacent over hypotenuse. So that's going to be 1 over root 5. Sine theta is going to be opposite over hypotenuse. So 2 over root 5. Now, because we have done our topics in a bit of a different order, you have not done double angle identities yet. We will be doing that in our next topic. But if you look at your formula sheet under your trig section, you'll see your double angle identities. Okay, so you don't worry about where they're coming from, just note that they're there and you can apply them. So cos 2 theta is 2 cos squared theta minus 1, and sine 2 theta equals 2 sine theta cos theta. So we do those in the next topic in Unit 2, so before your exam, so it'll become a little bit clearer, but at the moment you just need to be able to apply it. So we've got 2 lots of cos theta is 1 over root 5, and we need to square it, minus 1. So that's 2 over 5 minus 1, which is negative 3 over 5. Sine 2 theta is going to be 2 lots of my sine theta times by my cos theta, which becomes 4 over 5. So therefore, my matrix of rotation, which is cos 2 theta, sine 2 theta, and negative cos 2 theta, plug in those values, we have negative 3 over 5, 3 over 5, 4 over 5, 4 over 5. Okay, so write the matrix for a reflection and the line through the origin with inclination 2 pi on 3. So our matrix is cos 2 theta, negative cos 2 theta, sine 2 theta, sine 2 theta. It's on your formula sheet, but you'll probably start remembering it. Theta is 2 pi on 3, so 2 lots of that is 4 pi on 3. Now, 4 pi on 3 is 3 pi on 3 plus pi on 3, which is pi plus pi on 3. I would normally put this off to the side, but I don't have enough room. So we're in our third quadrant. So that means sine and cos are negative. Okay, you also have to remember your exact values. So this becomes negative cos of pi on 3, negative sine of pi on 3, negative sine of pi on 3, and the negative negative becomes cos of pi on 3. So cos of pi on 3 is minus a half. Sine of pi on 3 is negative root 3 on 2. So that's our matrix. Now the next part, find the image of, and it's given us 3 points under that reflection, and it says correct to 1 decimal place. So we have to multiply that rotation matrix, and it's going to be yuck because of all these square roots and fractions. Create a matrix for those 3 coordinates. Doesn't need to be that big, does it? 2, 4, negative 2, 1, 3, negative 1. And you're going to have to do this by hand because of all those square roots and fractions. So negative a half times 2 is negative 1. Negative root 3 on 2 times 4 is minus 2 root 3. Move across. Negative a half times negative 2 is 1. Negative root 3 on 2 times by negative 1 is minus root 3 on 2. Next, negative a half times 3 is negative 3 on 2. negative root 3 on 2 times negative 1, so plus root 3 on 2. This is gross. Next one, negative root 3 on 2 times 2 is a negative root 3. Be careful that I don't miss that negative. A half times 4 is 2. Now we've got negative root 3 on 2 times negative 2 becomes positive root 3. Half times 1 is plus a half. Finally, negative root 3 on 2 times 3 is minus 3 root 3 on 2. Half times negative 1's minus a half. Let's neaten that up a bit. So negative 1 minus 2 root 3, get a common denominator of 2. 2 minus root 3 on 2, minus 3 plus root 3 on 2, negative root 3 plus 2, 2 root 3 plus 1 all over 2, and negative 3 root 3 minus 1 all over 2. Now, it did say correct to one decimal place, so we can round all these. And in all honesty, you could probably just go to your calculator if you know you don't need an exact value. But, I mean, this could be in a tech-free paper, couldn't it? So always good to be able to do it by hand. If it was in a tech-free paper, you of course wouldn't be rounding at the end, but it's a possibility. So we're done. So I've run out of room. So going up there, my F is going to be 1 minus negative 1. Negative 1 minus 2 root 3. Negative root 3 plus 2, which is approximately negative 4.5, 0.3. My G image is 2 minus root 3 on 2, 2 root 3 plus 1 all over 2, which is approximately 0.12.2. And my image of H is minus 3 plus root 3 all over 2, minus 3 root 3 minus 1 all over 2, which is approximately negative 0.6. Might have to write that underneath. Approximately negative 0.6, negative 3.1. Let's verify it. Might make that arrow a little bit better. So we started with 2, 4, negative 2, 1, 3, negative 1, and then our image is approximate, so negative 4.5, 0.3, .1 and 2.2, and negative 0.6, negative 3.1. And I labeled that point incorrectly. It should be G.